Okay, so once you're in Google Classroom, you'll see that in the stream is the lab that we're doing today, Graphing Lab, Position versus Time. If you click on that, you will see a number of different things. Okay, you will see a Graphing with Google Sheets YouTube video, which is basically just there in case you've completely forgotten how to build a graph using Google Sheets. I'll walk through it really quickly after we get our data, just in case anyone has forgotten. Okay, and then there's this YouTube video, which I'm going to replace in a few minutes with the one I'm recording right now. Okay, and that one is just, I mean, when you're doing the lab report, you can review it and make sure you've done everything. Okay, there's also a class data set here. Unless you're not here when we do the lab, you're not going to need that data because you're going to have your own. Okay, and then there's a PDF document that is basically just a lab sheet that I'll have up on the board here. Okay, and then there's the Google Doc. That's the one you need. Okay, it doesn't say student Codere, it says your name instead. Have that open, okay, so that you can work from it, because you're going to want to fill in a few things here as we go along. It is the skeleton of the lab report, so that you just have to fill stuff in and not have to worry about the formatting. Okay? All right, so this lab, okay, what we're doing in this lab is basically checking something we kind of already know to be true. Okay? And that is how you can get the velocity of an object from a position versus time graph. Okay? So I would say your problem probably needs to sound something like that, since it is supposed to be what you're investigating in the form of a question. Okay? And we are looking at how to get the velocity of an object from its position versus time graph. So something along those lines in their own words, okay, would be good for the problem. Now, the expectations for the design part are as follows. Okay? You must both identify and explain all of your variables. Okay, now I say all, but I mean it's not going to be absolutely all of them. Okay, your manipulated variable for sure. Any responding variables. Sometimes experiments have more than one responding variable. Can you ever have more than one manipulated? No. Okay, and you must list and explain 3 controlled variables. Most experiments have more than that, but we'll limit it to 3 just for expediency. Okay. All right, so here's how the lab is going to go. This is the process you should go through when you're trying to figure out what your variables are. Look at the procedure. What is this lab going to entail me doing? Okay, here's what the lab's going to entail you doing. You're going to have one of these ramps. Well, it's not going to be a ramp because it's going to be level. Okay, it's not going to have any incline at all. It's going to be very, very level. So in order to make sure that it is very, very level, where should you put it? I would put it on the floor. I'm not going to say that the floor is perfectly level or smooth. It's not. But it's the closest thing we have. Okay? Now, is there a way you can check that? There is. Now, these incredibly fine examples of woodworking, okay, were built by Mr. Dickey and myself. They're 2 pieces of fairly high quality plywood screwed together. But over time, they have started to deform slightly. Okay, so there may be slight twists in them. Okay, if that's the case, you may or may not even notice it, and it may or may not affect your results at all. Okay, but when you place it on the floor, there is a way you can check if it's level. Right, you can use your phone. In the measuring app in iOS anyway, okay, there's a level, and if you just open that up and put your phone on here, it'll tell you if you need to adjust it at all. Okay? It's accurate to the nearest plus or minus 1 degree or so. Okay? It'll probably just tell you it's level, but if it does say something other than 0 degrees, you probably want to adjust it a little bit with maybe jamming a piece of paper under one corner or something. Okay? Because we do want it to be level. All right, so what you're going to do is you're going to place one of these carts on the track. This is the other reason why we're doing it on the floor. Then it can't fall off the desk and break. Okay? These carts are about $600 each. Okay? They measure a ton of stuff, which you will discover when we open up the data that they collect in Google Sheets, and there's like 20 columns worth of data that we don't need. All right, so they do record a lot of stuff. So you're gonna put them on the track. Now, the carts do have a little X, Y, Z indicator on their top surface. Okay, this is the front of the cart. Okay, the X arrow points this way. So put your cart on the track so that it moves in that direction. Otherwise, when you build your graph, the graph will tell you that the cart went backwards. Because from the cart's point of view, it will have if you push it the other way. Okay, so you're gonna put it on the track like this, okay, and all you're gonna do for 2 trials is just give it a little push. Okay, and it'll travel at a constant velocity, fairly close to 1 anyway, okay, for essentially the length of the ramp. Okay, and you're gonna stop it at the other end. All right, now, it's not a big push. Okay, we don't need this thing to be done. Okay, we want to be able to collect some data. These can collect data at 20 hertz. Okay, that means they will collect 20 data points per second. Okay, so they don't need to move for very long before you have a lot of data points to build your graph with. Okay, so what I'm saying when I say give it a push is just to do this. Well, maybe a little more than that. Okay, give it a little bit of a push. Like so, okay? And then on the second trial, make it go a little bit faster or a little bit slower. Okay, so not quite as hard a push on the second one, maybe. No, this one obviously needs a little bit of push. Okay, so you choose, all right? As long as we can get about a second's worth of data, we're good. Okay? Now, that means that as the experimenter, we are determining the interval of time over which the cart will travel. Okay? Does that affect basically everything else about the cart's trip? It does. Okay? And we, as the experimenter, are determining the time interval to be 1 second or around 1 second. Okay? So what variable does that make time then? Okay, so there you go. It's a bit of an answer for you there. Okay? You have to explain it, right? But the manipulated variable is time. Okay? And manipulated variables always go on which axis of a graph? They go on the x-axis. Okay? All right. Since this is a graph of, or a lab on position versus time graphs, what does that make our responding variable? Yeah, the position. The position of the cart should change as it travels along the track. Okay? How much it changes is a response to how long we let it travel for, which was our manipulated variable. Okay? So in your explanations, this is what I'm looking for. Right? The manipulated variable is time. And then in your explanation, I want to know how it's being manipulated and why. And the why can be what effect it would have on the experiment. Okay? Same for your responding variable. Okay? Responding variable in this experiment is position. How is it responding? Why is it responding? Okay? And then I need you to have 3 controlled variables. Okay? Those variables will come in 2 types. They will either be procedural or conditional. Okay? What condition did I kind of make a big deal about when we first started this? Whether it was level or not. Makes a big difference. Okay? I don't want to have somebody in the middle of the cart traveling pick up one end of the ramp and lift it up. Okay? That's definitely going to change the type of motion the cart experiences. Okay? So there would be one conditional control variable. Okay? Procedural controlled variables have to do with things you do the same from each trial. Okay? Now, in this experiment, we're kind of assuming that for that short period of time, what is constant about the cart? Yes, they are, and they are consistent. But what are we saying? Like, I know I give it a little push, but after I'm done pushing it, there's a short period of time where it travels at, a constant velocity. Okay? If that is constant, is it then also controlled? that might be important in that we're trying to calculate average velocity, we kind of need a straight line for that. Okay, I'm gonna let you come up with a third controlled variable, okay? Something either conditional or procedural that will be the same throughout the length of time that the cart travels, okay?
Do we need to identify if it's conditional or?
No, I'm just letting you know that I probably would like at least one of each. I mean, you're gonna have three, so you're gonna have two of one and one of the other, but I'd like to have both kinds in there. Okay, I don't care which one you have two of and which one you have one of, as long as both kinds are in there, okay? All right, so that's the process in future labs that you're gonna wanna go through, okay, in order to determine what your variables are, because I'm not always going to give them to you like I did today. Okay, it is the first one, so it's a bit of a freebie. Okay. All right, questions so far? For the hypothesis, what three words does a hypothesis need to have? If, and, then. Okay? The if part of a hypothesis deals with the premise you are working on. Okay? That is what you're investigating or what you think the cause of a situation is. That's what goes in the if part. Okay? The and part of a hypothesis briefly describes the experiment. Okay? And I mean brief. Your procedure will give it in detail. You just need to briefly describe it there. The then part talks about your predicted results and or what you'll be able to do with them. Okay? So for this lab, okay, the problem we were investigating was how you could get the velocity of an object from its position time graph. So, we can talk in there about what happens to the position of a cart as it's traveling at a constant velocity, okay, or something like that in the if part, okay, what that might look like, okay, what kind of relationship it might have on the graph, okay, something like that, okay, so you could even say like, if there's this kind of a relationship between position and time for an object traveling at a constant velocity, that might be a good way to start, something like that in your own words, okay. The and part describes the experiment, and a cart is allowed to travel along a level track at a constant velocity with position and time recorded. That's what we're doing, okay? Then, in the then part, okay, go back to here. In the then part, okay, I would say you should tell me how you can calculate, or how you will calculate, the velocity of the cart from your graph. Okay? From the graph. Tip. Do I need the graph to use V equals D over T? Do I need a graph or just the raw data to do it that way? Just the raw data. Okay? There is something you can do with the graph or get off the graph. The Google Sheets might even tell you that will give you the velocity. Okay, that one I leave up to you, but that's something that you'll want to talk about in the then part of the hypothesis. Okay? All right, obviously for you guys, the procedure and the materials are already in the document, so you don't have to do anything with those, you just have to follow the instructions. Okay, pretty straightforward. And then collect your data. Okay. Once everyone has their data, we'll talk about how to build the graph and what to do for the analysis. Okay, I don't want to overload you. Let's get the data first and then talk about what we're going to do with it. Okay, so here's what you need to do now. Get in your groups. Each group needs a cart and a track, okay, and one person to collect the data. Okay, once you've decided who's gonna use their phone to collect the data, that person needs to come up to me so I can show you how. Okay, how to connect to the cart, okay, how to start and stop the data, and then how to send it. Okay? Questions so far? Okay, couple of things. In regards to the carts, okay, they're expensive and they're delicate, right? If they get dropped, it can affect some of the delicate sensors inside, okay? I think this one's already had that happen because the wheels don't seem to be working quite right on it already, okay? Because it didn't move very well along my track here. On your track, there are two different sets of grooves, okay? There's these big deep grooves, you're not gonna use those, okay? And there's these little grooves here. These little grooves are exactly the distance between the wheels on these carts, so make sure you use the little grooves. Because if you put it in the big grooves, nothing will happen, because it will bottom out, okay? It doesn't work, they're for different style cart. Okay, so use the little grooves, okay? Make sure it's in there, okay, nice and square. Yeah? Okay. Make sure you're doing it on the floor, and beware of something, because sometimes this thing startles people, and then they drop the cart. There's this little black button right here. Okay? It releases the spring-loaded plunger that can be used in a conservation of momentum lab. It will startle you if you accidentally press it, and it happens all the time. People pull it out of the thing and then they drop it. Okay? So just be careful of that. And here's the other thing. If you're gonna set this cart down anywhere other than the floor, set it down in this position. Because then it won't roll off of anything. Okay? I see this happen all the time. People are like, oh yeah, and they set the cart on their desk, which is not level, and it rolls off the desk and breaks. Okay? They don't want to hear the cart crashing sound, so it'll be followed by the ambulance sound. I'm just kidding. Okay? So yeah, just be careful with them. They are pretty delicate. Okay? If there's any questions while you're collecting the data, let me know. But as I said, once you've got the materials, the person recording the data needs to bring the cart and their phone with the SparkView app open up to the front so I can show you how to collect the data. Okay? I'm going to keep this one because it's not rolling very well to use as a demo. So there are 7 more carts and 7 more ramps. Okay? So get into groups, get the stuff back to your spot, and come up here to get the data. Once the data has been shared, it should show up in your Google Drive. Okay? If you go into shared with me, it should be in there somewhere. Okay? So for me, it's right here, okay, because I shared it with myself. Okay? And it's Graphing Lab Data 2023. Yours might have a different name. If you didn't change the name, it's exporteddata.csv. Okay? So it's a CSV file, which stands for comma separated values. Basically, it can be turned into a spreadsheet easily. All right? So if you try and open that, this is what's going to happen. And you can't do anything with that. It's not editable. So, hopefully this option is showing up at the top. Open with Google Sheets. Okay? It should. If it doesn't, click the drop down and it's probably in there somewhere. Okay? Just click that. And Handy Google will convert it into a Google Sheet that looks just as messy, okay, as what you had before. Okay? Now, we don't need all this data. Okay? In fact, we need very little of this data. Right? We really only need 3 columns. Okay? We need 1 time column. Whatever trial was the slowest of the 2 is the one you want to keep the time data for, because it'll be the longest. Okay? And you want the position data for each of the 2 runs. If you had a run that didn't work, you just need to know which run number that is and know to delete all of the data for that run. Okay? So, to delete data you don't want to keep, just highlight the whole column, okay? Give it a right click, okay? Which on the Chromebooks is 2 fingers, okay? On the mouse pad at the same time, right? And just go delete column, okay? Not clear, delete it. So it goes away, right? And then we're going to delete a bunch of other columns. So I don't want force, acceleration X, acceleration Y, acceleration Z, acceleration, oh, there's position. All right, so I want to keep it. All right, so I've got all of those highlighted. Okay, same deal. I'm going to just right click or go to edit. Okay, and come on, delete columns B to F. They're gone. All right, so now I've got time for run 1. And I've got position data for run 1. Okay, now I'm going to go about deleting a bunch of other data. Okay, so click at the top. Okay, and I'm going to go all the way over, all the way over, all the way over to here, because I don't need any of that data. And I'm going to go to edit, delete, column C to N. Okay, now I've got time, position run 1, position run 2. That's all the data I need. Now I can delete everything else. Okay. Everybody with me so far? Okay. This is what you should end up with, is just this data. Time for run 1, position for run 1, position for run 2. This is the part where we edit our data. Okay? We're not like changing our data to meet what we want. We're taking out the stuff we know didn't apply to what we were doing. Okay? If you look at my data right now, you can see that I got all these zeros for my position data. That's because that's where I started the timer or the recorder, and I hadn't pushed the cart yet. So the cart was just sitting there. Do I want that data on my graph? I don't. But it's sometimes hard to tell where you want to start, which points you want to take off. So at this point, you want to build the graph. Once you have the graph, you can go, oh yeah, I want to take off all these points and take them off easily. Okay, so to build the graph, you're gonna put your cursor in the top corner there, the top left corner, and highlight all of the data. Okay, so I recorded 6.5 seconds worth of data when I did this by myself. Okay, because, well, it's harder by yourself, right? So I've got that, and now to build the graph, okay, hopefully everyone remembers how to do this from Science 10. Insert, chart, and this is what's in that using Google Sheets video, so if you get behind me, don't panic. Okay, all right. So it's built this graph, which, hey, that's not bad. Okay, that's actually exactly what I wanted. All right, was a graph that looks just like this with 2 different runs on it, one faster than the other. But there's a flat part here and flat parts here that I don't want on my graph. Okay, so now that I have my graph, now I can look at what points need to come off of the graph. Okay, so if I'm looking at run 1, that's my blue data. Okay, I can tell that that cart didn't start moving until like just before 2 seconds. And in fact, if I had a pointer, if I had a mouse, I'd be able to hover over any one of these points on the graph, and it would actually tell me the X and Y values. I can't do that on the panel here, okay? But you can do that if you have a Chrome. Okay, there we go. All right, so it told me here, there's the point that I highlighted has a X value of 1.6 and a position of 0.0873, so that's probably one I'd want to keep. All right, so I'm just going to go back, and I'm going to go through my data. And I'm going to move this up where I can see it when I'm doing that. This takes so much longer on here than it does on a regular one. Okay, so I'm going to get rid of a bunch of these zeros. I'm actually going to keep the first one because I want my starting position to be 0. Right? So what I'm going to do is delete this 0 here, okay, and I'm gonna go all the way down to probably this number here, which actually says I moved backwards slightly, which was probably the instant I gave it a push. I may have just pulled it back a little bit when I went to push it. Okay, so I'm gonna get rid of that by highlighting all of those cells. Okay, now here's the important part, guys. You don't just want to hit delete. It'll leave all these blank cells, which you don't want. Okay, so what you do when you've highlighted all these zeros, and I'm sure you all have some of these at the start of your graph, okay, is you want to go to edit, and the same thing we did a few minutes ago, delete, but you want to say cells and shift up. So it'll delete all these cells and bring all the data below up, so you don't have a gap in your data. Okay, and that's what we want it to do. So you hit delete, cells, and shift up. Okay, when I do that, it shifts my data up there, and now look at how my graph has changed. Okay, now my blue line does kind of start back here at 0. Okay, so I did a good job of taking off the points that didn't apply, okay, on that one. Now I've got to do the same thing at the end here, okay, where my cart kind of sits still for like the last 4 seconds or so of this experiment. So I'm going to say that that probably starts at just before 3 seconds or so. How much data did we say we wanted to have? How long? 1 second. Okay, so can I just delete everything after 1 second at this point? Okay, that way I'm obeying what I said I was doing, which was manipulating time. Okay, I said this experiment was going to run for 1 second. I'd better only have data for 1 second. Okay, so for the blue line, I'm going to go down to 1 second, which is right here, highlight that box, and then I am just going to delete everything after that. So I'll scroll right to the bottom. Here, hit shift. Okay, and I'm going to delete, whoop. No, I don't want to do that. And I'm just going to delete all of that. And I don't need to worry about shifting up because there's nothing there, but I can do it anyway. Okay, so now I don't need any of that stuff. Now I got to do the same thing for my second run. And if you go back up now, you'll see that, look, my graph only goes that far. Now I am going to delete all this other stuff over here as well so that my graph expands and looks nice. Okay, I don't want to leave like this little nub here that I'm dealing with later. Okay, so now I'm going to look at run 2. It looks like it starts right at 2 seconds. So I'm going to go from 0 and go to 2 seconds. Okay, and delete and shift up just like I did before. Okay, and then I'm going to do exactly the same thing I did here, and I'm going to delete everything after 1 second. Okay, look at my graph now. Is that a lot better? I got 1 second worth of data for both carts.
Do you want it as lines or as scatter plots?
I want it as scatter plot. Yeah, so if it didn't default to scatter plot, make sure you tell it you want a scatter plot.
Do you want us to have a trend line in there?
I'm going to talk about that in a minute. Yes, I do. Yeah. Okay. Now, guys, if you're not here yet, don't worry, don't panic. Okay, there'll be time for me to help you. All right. Now I want to put the trend line on there because the trend line will give me the equation that I can then use to do all of the analysis. Okay, so when I go into here, okay, I'm just going to click on my graph, go to edit charts. Okay, hopefully you guys have done this stuff before. Okay, and I'm going to go to customize. That's where I can change the title and make it more meaningful and all that stuff. Okay, but for right now, I just want to go to series so that I can say that I want, scrolling down here, a trend line By checking that box, now I've got a trend line or a best fit line for both data sets. And I want the label. So once I click trend line, all this new stuff opens up for me. I want to click on label and say use equation. When I do that, it puts a little legend up here at the top that gives me y equals 0.355 times x plus negative 0.0298 for the blue line, and y equals 5.65 times x plus negative 0.0416 for the red line. Okay, now once I fix the title and the labels and stuff on the axis, I'm good. Okay, that graph is done, and I can just copy and paste it into my lab report from here. Okay? All right, if you got behind me, that's okay. All right, I'll help you out here. Maybe during nighttime or something like that, I can help you out with the graphic part. Okay, now, want to quickly talk about what we're doing with this graph once it's built. Okay, so back in your lab report here, okay, the analysis, okay, so this is what you're doing with your data, okay, using the spreadsheet software, plot the graph, you've done that, okay, and using y equals mx plus b, so it's telling you how to do this, using y equals mx plus b, determine the velocity of both cars. So what do I want to see? I want to see that calculation for each car. Okay, you can either type it in or do it on paper, take a picture of that and insert the picture. I don't care which, but you're only handing in this electronically, so don't bring calculations to me on paper later. Okay? All right, everybody follow there. So that's all you have to do for the analysis. You got the graph built and you show me how you calculated velocity using y equals mx plus b for each car. Okay, that's all there is. Then you've got your conclusion, copy paste your hypothesis, and then tell me if you can accept it or reject it based on what you did in the analysis. Okay, so were you able to calculate the velocity of the carts? If so, tell me how and whether you can accept or reject based on that. Then, 2 sources of error. Okay, 2 sources of error in this lab, okay, and how you can fix them in the future. All right, think about a couple of little things that may have happened. Maybe your ramp maybe wasn't perfect, and maybe it was a little bit twisted or something like that. Okay, those kind of things are experimental error that you can list. Okay. All right, I will come around and help people out now.